Hey, it's Sukrit from STEM Quarter, and in today's video we're going to go over second and higher order derivatives. Up here we have our function f of x is equal to 3 times x to the power of 6. We can also write it as y equals 3 times x to the power of 6, where y of course is our output variable. We know how to take the first derivative. We can express it as the form dy over dx, which means the derivative of y with respect to x, or we can write it as f prime of x, which just means the derivative of f of x. And that of course is going to be 18 times x to the power of 5. We just had to use the power rule for that. But the first derivative is not the only derivative we can take. What if we want to take the derivative of the derivative? So we want to take the derivative of 18 times x to the power of 5 in this case. Well, there is a term for that. It's called the second derivative. And we're just going to take it now. So this is just going to be 18 times 5 times x to the power of 4. So it's going to be 90 times x to the power of 4. But what term notation do we use over here? Well, this is actually going to be written as f double prime of x. So we're going to write 2 tick marks over here. So this just means the derivative of f of x. What notation do we use here? Well, all we're doing is we're technically just taking the derivative with respect to x of dy dx. So we're taking the derivative with respect to x of the derivative of y with respect to x. And I know this notation may look a bit confusing, but this is actually how we write the second derivative, d squared y over dx squared. So this d squared, think what is d squared means it's a double derivative, and x squared means both times we're taking the derivative with respect to x. So d squared y over dx squared just means the second derivative of this function, the second derivative of y with respect to x. So we can write it as d squared y over dx squared. Now we don't just have to stop at 2. We can actually keep going down. We can take the third, fourth, fifth, sixth, seventh, so on and so forth. So let's actually do that. What's the third derivative? It's going to be 360 x cubed. Then the fourth derivative, that's going to be 360 times 3 times x squared. Next one's going to be 360 times 3 times 2 times x. Sixth derivative will be just 360 times 3 times 2. Remember, derivative of x is just 1. What's the seventh derivative going to be? Well, this is a constant. It's just going to be 0. And for the eighth derivative, well, derivative of 0 is just 0. So you can see that we can keep on taking higher and higher orders of derivatives. First, second, third, so on and so forth. But once you reach the seventh derivative, if you keep taking the derivative of that, any higher order derivatives are just going to be 0. And this is generally the case for power functions. However, let's take a look at the sine function. Let's say g of x equals the sine of x. What's the first derivative of this? G prime of x. Well, that's going to be cosine of x. G double prime is going to be negative sine of x. G triple prime is going to be a derivative of negative sine of x, and that's just negative cosine of x. And you probably predicted this by now, but what's the fourth derivative of g of x? Well, the derivative of negative cosine of x with respect to x is just sine of x. So you can see we've kind of gone full circle over here. So if we just keep taking higher order derivatives like 5th, 6th, 7th, millionth, billionth, whatever, it's going to be one of these 4 functions over here. So I hope you found this video helpful. Just understand that the first derivative is not the only order of derivative we can take. We can take second, third, so on and so forth. And the notation we use is the number of tick marks. So the number of tick marks like in f prime, that represents which order it is. And for if you're using this notation, like the derivative of y with respect to x, it's going to be d squared y over dx squared, or d cubed y over dx cubed. So this will be d cubed y over dx cubed. This is the notation you'll be using if you want to express a derivative in this format for higher order derivatives. Once again, I hope you found this video helpful, and I look forward to seeing you in future lessons where we will be making use of the second derivative extensively.